I'm from Red Hat. I'm responsible for static analysis of Red Hat Enterprise Linux. And I'm now experimenting with formal verification tools, which is what this talk is about. Let's start with static analysis. Red Hat uses static analyzers to find programming mistakes, which we also call bugs. The sooner in the release cycle we find a bug, the more money we save. Here is an example. Shell check detected a programming mistake in the init script of squid. Squid is a commonly used proxy server, and init script is a tiny shell script that starts and stops the server. The highlighted line of code removes PID files from the specified directory. However, if the variable is unset, it removes the entire root file system. And this really happened in our testing environment because the programmer forgot to set the variable. You can have a look at the related bug report in Red Hat Bugzilla. The QE engineer expected a service to be restarted, while the command actually removed all files from the machine. Now, thanks to shell check, we are notified about such mistakes before the code ever runs. And it is not the only reason why we use static analyzers. Static analysis is also required for common criteria certification, which applies to Red Hat Enterprise Linux. Static analyzers become more and more popular in open source communities, but the role of Red Hat is special because we statically analyze a whole Linux distribution. As you can see, it is a big piece of software. Red Hat Enterprise Linux consists of approximately 300 million lines of code. And we have the tooling to statically analyze this amount of code fully automatically. The last time we analyzed the distribution, we got reported approximately 370,000 potential bugs. This means that we have approximately one potential bug in each 1,000 lines of code. The distribution consists of approximately 3,000 RPM packages. Each of them is slightly different, so we need to handle different build systems, coding styles, or even programming languages. But we do not have the manpower to customize static analyzers for each single package, so we develop a universal tool that can statically analyze the RPM package fully automatically. And this tool is called CSMOC, and I will talk about it later. On each major release of Red Hat Enterprise Linux, we statically analyze all the packages and review the results. But once the release is out, we do not want to keep fixing the outstanding bugs because it is easy to create new bugs while trying to fix the existing bugs. So on minor updates of RHEL, we check for potential bugs that did not appear in the previous release. And if a new potential bug is detected in an update, the developers are notified, and they have to fix the bug or explain how it appeared in the update. So we really like to use static analyzers because they are fast and flexible. We can statically analyze basically anything that we can compile. And the analysis usually does not take much more resources than compilation of the package. On the other hand, the precision of some static analyzers is limited. So we often fight with so-called false positives and false negatives. In the first case, the tool reports a bug when the code is actually correct. And in the second case, the tool overlooks some bug. And this causes human resources to be wasted because someone has to review all the false positives, and if we miss an important bug, we have to fix it in an already released product, which is extremely expensive and risky. Luckily, we have formal verification tools, which this session is all about. These tools can guarantee 0 false positives and 0 false negatives. And they can even prove that a program is correct. Of course, we need to carefully specify what it means for a program to be correct. Two very interesting tools are developed at Masaryk University here in Brno. First of them is Divine, which is based on explicit state model checking, and the other one is Symbiotic, which combines instrumentation, slicing, and symbolic execution. Both of them will be presented separately after my talk. Of course, Divine and Symbiotic are not the only tools on the market. Many research groups develop their own verification tools, and these tools attend the international competition on software verification, abbreviated as SVComp. It is worth to say that Symbiotic has been quite successful in this competition, and they won the software systems category this year. As I said, formal verifiers are more precise than static analyzers, but it is, of course, not for free. Formal verifiers are also more difficult to use. Unlike static analyzers, formal verification tools are usually not well integrated with the system compiler. So it may easily happen that they fail to compile our code. In some cases, they compile the code successfully, but they understand it differently. Consequently, we might get misleading results, even though we use, in principle, more precise tools. These tools are also much more hungry on resources. They can, for example, run out of memory even on a small input program. On some input programs, these tools run forever without providing any results. And in general, there is no correlation between size of the input program and the time needed for its verification. Compared to SVComp benchmark, RPM packages are not so nicely isolated. Each non-trivial package depends on some external libraries, and these libraries cause problems to formal verification tools. Also, the entry point is not always obvious. Some RPM packages have no main function and all, while other packages have too many main functions. Some packages use fork, exec, DL open, and so on. As you have seen, it is not always easy to use formal verification tools, but we have made some progress on integrating these tools into our environment. We have packaged Symbiotic and Divine as RPMs for Fedora. Thanks to this small step, it is now much easier to install these tools locally and experiment with them. Symbiotic has been extended to report multiple bugs in one run. This may sound like an obvious feature in case of static analyzers, but it is not very common in case of formal verifiers. These tools usually finish as soon as they report the first violation of the given property. We started to experiment also with CBMC, which is another formal verification tool. It attends SVComp, but it is not developed in Brno, so we can use it for independent comparison. Currently, we are developing output formatters for Divine, Symbiotic, and CBMC. We want to make them use a unified output format that is compatible with the format that we already use for static analyzers. Here you can see the ultimate goal of this project. Our tool CSMOC for running static analyzers is going to be extended to run also formal verifiers. As we use it now, CSMOC takes a source RPM package, runs various static analyzers on it, and returns the list of potential bugs in a unified machine-readable output format. CSMOC provides an interface for plugins. The small blue boxes in this picture are CSMOC plugins. Each of them is responsible for a single static analyzer. And thanks to this plugin interface, it is easy to plug additional tools as needed. So we are going to develop CSMOC plugins for CBMC, Symbiotic, and Divine. Once we have these plugins, we can reuse all the infrastructure built on top of CSMOC to run formal verification of RPM packages automatically. Of course, it is the long-term goal. We are not there yet, but we are working on it in some small steps. Thank you. I'm ready to take questions.
Thank you. So, questions? Tomáš? Fyodor?
Yes, I would like to ask regarding...
Wait for the mic, maybe.
Okay.
I'll bring it over.
So thank you for your talk. I would like to ask you regarding the output of the CS mock. So you basically output a list of bugs, right?
Yes, it
but
can look like this.
Yeah, but the issue is that if I am a developer and you give me a long list of bugs, and I am working on certain module or on a certain feature, I will not repair those bugs. So are you addressing like something like diff analysis in the CS mock? So you report only those bugs that are new, like from the previous commit or the previous version?
Yes, exactly. That is what we do on RHEL updates, on the updates of Red Hat Enterprise Linux. Because we know that some packages have too many potential bugs. It could be false positives because of bad coding style and so on. But we do not want to fix them all because we could introduce new bugs while trying to fix them. So we do the differential scans and report only the bugs that did not appear in the previous release. So we have tools that operate with this format, and then they can give you the difference of 2 runs of static analyzers.
Okay, other questions? So in fact, I have one, maybe a little bit specialized. So it's clear that you chose Symbiotic and Divine because they are from Brno, but why CBMC out of many tools that are in SVComp? Why not Ultimate or...
It has been recommended to us
checker.
multiple times when talking about this effort, so why not? We should give it a try.
I'm not speaking against, just
It's,
there are many more.
One of the reasons could be that CBMC, for example, is already in Fedora. So we don't need to take care of the packaging. We can just take the package and run our experiment. So it was maybe more ready for us than other tools on the market.
Okay.
But there were more reasons, of course.
Okay, some other question? Okay, no, so then let's thank Kamil once more.